Okay, here we have these two functions. We're going to sketch the graph and look at the region. Then we're going to rotate that region around a vertical line x equals 3. And so that will result in a solid rotation, and then we're going to find the volume of that solid. So it's a pretty involved problem. The thing is, it does help if we can sort of quickly sketch these curves. So here I have y equals x, or x equals y squared. That's a parabola opening to the right. And I mean, I just keep doing these parabolas over and over. But look, if you put in y is plus or minus 1, you'll get x is 1. Y is plus or minus 2, you'll get x is 4. So you can sort of sketch that hopefully a little bit quickly. The other, that's x equals y squared. So I just did x equals y squared. The other guy, x equals 1 minus y squared, is a parabola. And this parabola is opening to the left. Now, if you just look at, if you just look at y equals negative y squared, x equals negative y squared, that's a parabola that opens to the left. Let's see if I can draw that with this program. It's a parabola that opens to the left. However, this guy, what we do is we add 1. And what that does is it shifts it to the right by 1. And I would say, are you sure right or left? Well, what we should probably do is plot some points. I'll put the easy point. Y is 0, x is 1. Okay. And so, but you can plot more points to just verify that. But hopefully, you know, it's one's a parabola opening to the right, one to the left. But you plot a few points just to verify. Trust but verify. It's a Russian saying, which former President Reagan used when dealing with Gorbachev. Okay. Premier Gorbachev. All right. Okay, let's not even talk about that right now. Okay. Here we go. This is the region we're talking about here, right? Okay. So let's see if I improve my shading. That's the region we're looking at. Now, for intersection, I'm thinking I did it wrong because, oh, maybe not. I don't know. The intersection doesn't seem to come out so nicely. Most of these problems, it seems if I just carefully sketch the graph, I get the intersection. So I'm thinking, what am I doing? Okay, so I have x equals y squared, x equals 1 minus y squared. No, it looks like now I'm looking at this more carefully algebraically. I think this is going to indicate that that picture is just about right. So it's plus or minus 1 over square root of 2. Rationalize the denominator, maybe. I'm going to throw out the idea, going on a limb, that if I leave it as with the irrational number in the denominator, I'm going to throw out the idea that it's actually going to be easier to simplify later on. My very last answer, I might rationalize the denominator. But what we're going to do now is we're going to rotate around the line x equals 3. Now, here's my whole thing with graph paper, is by using graph paper, I get too uptight, and it sort of cramps my style a little bit. So I'm going to just hopefully not get too uptight about the whole thing or too bent out of shape. I don't know, whatever. Just sort of let it go. Let my freak flag fly there. Okay. Yeah, I just gotta go with it. Ride the wave. Shine your light. Okay. Okay, anyway, it's weird how sometimes you make something that looks messy and it looks sort of believable. All right, what's going to happen then, though, is when we do make a cut, which I'm going to do, I'm going to cut this, slice this. I'm going to take this slice, and what does the slice look like? I'm going to do this a little faster than sometimes I do. I sometimes get carried away with the software provided, software and drawing neatly. That sort of was messy. But let me just do it sort of quickly. What I get is a washer. So what does that mean? That means that the face, if I look at it, is a circle with just the face. The shape is a circle, and then there's a piece missing. There's a piece taken out from the middle. Can't say that helped. Sort of don't like that. Okay, anyway, here we have a washer. I think the biggest thing is that we see that that's dy is that thickness. So let me go ahead and I'm going to just stick to this and put this into the formula that I came up with for the volume. The volume is going to be the integral from C to D, which I'm using C and D instead of A and B because I'm indicating the y values. And then look, it's going to be pi. Okay, if we look at this face here, it's a circle. And that's going to be pi r squared is the area of the circle. But then we subtract the little circle inside, the one that was eaten up by a mouse or something. It's disappeared from the inside. So I have the larger face, which is a circle, pi r squared, minus the smaller face, pi r squared. The thing is that's tricky to understand is that the radius is the function, which is, say, x equals f of y, subtracting the line. So the radius is, I don't want to put that line there, but you go from the x value on the right and you subtract the x value of L and x equals L, and that gives you a radius. So you get f of y minus L, where f is the one that's farthest away from the axis of rotation. So I call it outer. And then I look at g of y minus L, which is going to give the smaller radius. And it's the same argument, but it becomes a big mess when you draw that. And that's what I'm going to call inner. In this case, we see that this is the integral from -1/rad2 to +1/rad2. I'll take the pi out, and I'll have the outer function, the one farthest away, is x equals y squared. So I'll put y squared, square that, minus the inner, oh, that's not correct. Sorry, everybody. Minus the line L, which in this case is 3. So in this case, L is equal to 3 because we're rotating around x equals 3. Square it, minus the inner function, the one closer. Oh my gosh. Okay, I thought everything was not super good, but it was not that bad. The inner one is y squared. As we can see in the picture above, y squared is closer to the axis of rotation, and it's x equals 1 minus y squared is farther. Okay, I'm going to keep going in this video. Closest is x equals 1 minus y squared. That is the inner. The outer is x equals y squared. Okay, this was right the first time. That's y squared. And then this is 1 minus y squared. If I get a negative answer on this, I'm going to, think that I did it wrong. But look, 1 minus y squared is closer to 3 than y squared is. Also, I'm going to find this is an even function anyway. So I am allowed to multiply by 2 and go from 0 to 1/rad2. But I can see that the top part above the x-axis has the same volume as the part below the x-axis. So I'm going to multiply by 2, go from 0 to 1/rad2. It's just going to make it a little easier. If I expand this gives y squared squared minus 2y squared plus 9. No, it's 2 times 3y squared plus 3 squared, which is 9. then minus, oh, I have to work this out a little bit. This is going to be 1 minus 3 is negative 2 minus y squared, or it's easier for me to see if I write this as negative y squared minus 2 squared. So yet one more line. I need another page here. It's too much, right? It's not too much, but it's definitely not a super easy problem computationally, at least. So anyway, let me just charge ahead. Y squared is y to the fourth minus 6y squared plus 9. I have that part. This part, it's okay. What it is negative y squared, which gives y to the fourth. And then I multiply these two together. 2 times negative y squared times negative 2 makes plus 4y squared, and then negative 2 squared is 4. That's a little bit tricky. I think it's easier if you factor out negative 1 and square it, you get positive 1. See, this whole thing right here is the same as y squared plus 2 squared. If you factor out the negative 1 and square it, then you get that. Okay, but this makes 2 pi 0 to 1 over rad 2. Y to the fourth minus the y to the fourth will cancel. And so I'll get negative 6y squared minus 4y squared makes negative 10y squared. Then 9 minus 4 makes 5. And then this will give 2 pi, I'll integrate, and I'll have negative 10y cubed over 3 plus 5y, and I go from 0 to 1 over rad 2. So I get 2 pi times negative 10 thirds, 1 over rad 2 to the third power, plus 5, 1 over rad 2. And then I subtract 2 pi, and everything inside is going to be 0. So this makes 2 pi, negative 10 thirds, 1 over rad 2 squared, which is 1/2, times 1 over rad 2, plus 5 over rad 2. That makes 2 pi, negative 10 thirds. I really would help. It would help if you see a mistake, please just speak up. Let me factor out this 1 over rad 2. Let's just factor that out. Or is that too complicated if I do that? I think it's going to be easier. And I'll have plus 5, and then I'll factor out the 1 over rad 2. So I don't know if that was too clever, but anyway. Negative 10 divided by 2 is negative 5, so I get negative 5 thirds plus 5 times 1 over rad 2. And in fact, I can go ahead and factor out 5, and I get negative 1/3 plus 1 times 1 over rad 2. So I get 2 pi times 5. Negative 1/3 plus 1 is 2/3. And then I have 1 over rad 2. So then, okay, just should I slow down a little bit? But 5 times 2 is 10, times 2 is 20. So I have 20 thirds pi times 1 over rad 2. But now I feel like I should rationalize the denominator. I feel that that's what the author would do in their answer. So I'll write rad 2 over 2. And so this will give 10 thirds pi radical 2, or maybe 10 radical 2 over 3, 10 radical 2 pi over 3. Man, that was a lot. Oh, my confidence that I can get that right. Without, which poem was that? It was number 17. Oh my gosh. Yes. Day for me, because yesterday I made so many mistakes in my class that it was people were feeling sorry for me, just thinking like I was I don't know, just like on the way out, like I needed to retire and go work at Disneyland in the parking garage directing traffic or something. But I think I can still do this for a little while, teach first year semester calculus for a while. Okay, any questions about that? It's a lot of stuff. Do you really need to know stuff that well to do your career? I'd say if you're going to be a engineer or a math or physics, you sort of like, if you had a heart surgeon, you'd hope a heart surgeon could do some math. Just, just you want a smart person there. Okay.